Hey, what's up, Logic fans? Welcome to our 7th video on propositional semantics. So we're going to cover section 2.7 of the text, where we encounter one of the most important notions that we've been building up to, and a notion that will occupy us throughout the rest of the text. This is the notion of validity. Let's rock. Okay, so recall all the way back to chapter 1, right? Where we said that validity, or rather we didn't really use that term as much. We did in section 1.1, but recall that in chapter 1 we were sort of discussing what's the purpose of logic, and we saw there that logic is the study of inference, what follows from what and why, okay? Validity is the logician's technical sense of following from. All right, so we were coming to a sort of forward point in our studies. We've laid a lot of groundwork. In chapter 1, we developed a lot of symbolic apparatus. Throughout chapter 2, we've been concerned with supplying that symbolic apparatus of chapter 1 with truth values, right, with semantic analyses. We're now going to provide a semantic analysis of following from, that is to say, a semantic analysis of validity, okay? So our fundamental unit of study that we need to get in front of us before we can do that is the notion of an argument, right? Because when you have an argument, you've got a couple of premises and you got a conclusion, and the idea is that the conclusion of the argument is supposed to follow from the premises. So we're going to see if we can't figure out a way to detect whether or not an argument is valid, that is to say, to detect whether or not the conclusion of an argument really does follow from its premises. So let's remind ourselves from section 1.1 of what an argument is, all right? Now, an argument is a finite, non-empty set of propositions, one of which is the conclusion, the rest of which are premises. And we typically display arguments in what's known as premise-conclusion format. Let's give an example so that you feel comfortable with this. Okay, so here's an example of an argument. All right, and there's a lot of features of this to note to make sure we're unpacking all of this correctly, okay? So first of all, notice that this is a set of propositions, right? So we can just consider this a set of 3 propositions, one of which is the conclusion. This one is the conclusion as indicated by the C here, which we're going to try to make regular use of to indicate the conclusion. Also, the conclusion is signified by the 3 dots, meaning therefore. So the idea is 1, 2, therefore, C, and this is what we call premise conclusion format. So 1 and 2 are clearly identified as premises, and what follows from them is indicated by C and the therefore symbol. Therefore, for as a quadrilateral, is the conclusion. So this argument is in premise conclusion format, and it is an argument, right? It is a finite, non-empty set of propositions, one of which is the conclusion, the rest of which are premises, all right? Now, finite. What that means is that, of course, in any given argument, all you ever have is one conclusion. Okay, you have it exactly one conclusion in every argument. Now, that's fine. What the finite part means is that basically the premises, okay, are finite. That is to say, there's a definite amount. In this case, there are 2 premises exactly. You can have 10,000, you can have 1,000,001, okay, but you have to have a finite amount, all right? There has to be a definite amount of them. In other words, we do not consider examples of sets which have infinitely many premises, okay? That's outside of our scope, okay? So that's not going to count as an argument for us. So an argument is finite. It's non-empty. That is to say, since we're defining an argument in terms of a set, we do have to note that that set has to have at least one proposition in it, okay? You can't just have an empty set and have that be an argument, okay? Incidentally, we will count things like oh, I don't know, let's just suppose we had an argument and all it had was one proposition in it, and it just sort of said, oh, I don't know, grass is green, something really generic, okay? This would count as an argument, all right? It's finite and it's non-empty. Intuitively, we would think of this as sort of repeating itself, so it would have one premise and the conclusion would be grass is green as well. So technically, just one proposition is going to count as both premise and conclusion, and as we'll note later, all such arguments are valid, okay? But so it's a special case that you're not going to have to worry about too much, but it's worth noting. So it's finite, it's not empty, it's a set of propositions. We display the argument in premise and conclusion format. Now, one feature of this definition of arguments that you need to be familiar with, okay, is that the idea is any set of propositions counts as an argument, okay? So our purview here is quite general, all right? The premises and conclusion do not have to be related to each other in any particular way. They don't have to be related to each other in any way. So, for example, this right here, this is an example of an argument. It satisfies this definition. It's a finite, non-empty set of propositions, right? The definition does not require the premises to be related to each other or related to the conclusion in any way whatsoever, okay? So this random assortment of propositions is actually an argument, okay? So this raises the question, right? Like, okay, well, this argument seems to be an argument in which, the conclusion follows from the premises because the premises and the conclusion bear some resemblance to one another. This would appear to be an argument in which the conclusion does not follow from the premises, and the premises and the conclusion seem to be completely unrelated to one another. So how can we formally decide which of those arguments have conclusions that follow from their premises versus those arguments which do not have conclusions that follow from their premises, okay? That's the big task, and that's what we're going to learn today. So let's start with our first definition of validity. Validity, a valid argument has premises, has a conclusion which follows from its premises. An invalid argument does not. And before I put the definition up there, just let me say that an argument is either valid or invalid. Okay, those are mutually exclusive and mutually exhaustive categories. You pick an argument out of a bucket, it will either have this property or it will have the property of being invalid. Either it will have this property or it will not have this property, okay? Same for any argument you pick out of your hat, all right? So let's take a look at the definition. So you need to memorize this definition right away, okay? An argument is valid. All right, so here we go. An argument is valid, our central concept, if and only if every assignment, okay, so here's your test. Every assignment which makes all premises true also makes its conclusion true. A little bit of jargon, right? But we're going to go through an example to make sense of this. But you do need to know this definition and know it well. So let's go ahead and work through an example to make sure you're understanding all aspects of it. So first of all, here's an argument, all right? Now let's assign some some proposition constants here. So F is going to stand for the proposition that Fred is a square, okay? And we'll do Q to stand for the proposition that Fred is a quadrilateral. Okay, now using F and Q, can you rewrite this argument using F and Q, using capital letters and the logical connectives, okay? So, for example, this here would be F, and this here would just be Q. What would the first premise look like if you were to translate it into symbolic notation using this? Pause now. Okay, it would just be if F then Q, right? Okay, so what we've done here is we formally translated our argument into symbolic notation. Now what our definition says is that every assignment which makes all premises true also makes its conclusion true. So we've got to convert this argument, we've got to produce a truth table for this argument, okay? Now this argument has 2 propositional constants that occur in it. Therefore this whole argument has 2 squared or 4 possible assignments for it. Let's go ahead and get those on the board. Okay, so the propositions that occur in this, the propositional constants occurring in this argument are F and Q. Therefore, we have 4 assignments, and we're just going to do this the absolute standard way we've done a million times by now, okay? So first one, it can go true, false, and then this one can go true, true, false, false, all right? So here's an assignment of this argument. Here's an assignment of this argument. Here's an assignment of this argument, okay? And our definition says that every assignment which makes the premises true, all of them, okay, also makes its conclusion true. So what we have to do is we have to have a truth table that presents the premises and the conclusion. Now, in this particular case, since the premise here just is one of the propositional constants, we've kind of already got it. Same thing for the conclusion. So we don't have to repeat that. I'm going to, just so you can see this whole thing done out correctly. So our first premise, okay, is this, right? It's if F then Q. And that's right here. So we don't need the 1, but the idea is that we've got our premise here, okay? Our second premise is just F, and our conclusion is Q, all right? So what we're going to have is a truth table that looks just like this, all right? We've got our propositional constants lined up here, okay? And then we've got the premises lined up here and the conclusion lined up last, okay? And that's what you're going to want to do. So the question is on this assignment of the argument, what happens to the premises and the conclusion? On this assignment of the argument, what happens to the premises and the conclusion, and so on for all of them. So let's go through this together. Let's take a look at the first premise here. If F and Q are both true, then the first premise is true. If F is true and Q is false, right, then the first premise is false, and so on, okay? Now, since we've already got F already here, all we have to do is sort of retranscribe this. This is why I was saying that you don't have to redo this, but in general, it's good practice to line up all of the premises and then the conclusion here. And again, we've got the conclusion here, and so we're just going to retranscribe that there, okay? So if F is true, then F is true. If F is true, then F is true. If F is false, then F is false, right? Same thing for the conclusion Q. All right. Now, let's take a look at what we've got here. What we have is a complete exhaustive truth table for this argument. And the question before us is whether or not the conclusion follows from the argument. Is this argument, in fact, a valid argument? Well, to be valid, it has to be such that every assignment which makes all the premises true also makes its conclusion true. So what we've got to do is we've got to look through here, right? Because we've got our premises here, and we've got our conclusion here, and we got to look for the cases where all the premises are true. Every assignment that makes all the premises are true. It doesn't matter what happens to the assignments that don't make all the premises true. We're only concerned with the assignments that make all the premises true. So here's an assignment which makes all the premises true. Does it also make the conclusion true? Yes, it does. Okay, so far so good. Is this an assignment which makes all the premises true? No, it's not. Is this assignment an assignment which makes all the premises true? No. Is this an assignment which makes all the premises true? No. So we've got 4 possible assignments in this case. Only one of them makes all the premises true, and on that one, the conclusion is also true. Therefore, every assignment which makes all the premises true also makes the conclusion true. In other words, this is a valid argument. Okay, it satisfies the definition of validity. This argument is such that if all the premises are true, the conclusion must also be true. In other words, the conclusion follows from the premises. Provided the premises are true, the conclusion is as well, all right? So this is a good argument in that respect. This is, in fact, a valid argument. Okay, I want to give you a lot more examples and note so many other features of validity, but we're running a little low on time here, so we're going to spill into the next video, 2.7b. Look for that, and we'll pick up the conversation there.